Alright, so this video will serve as a little mini crash course in completing the square. It's a method for solving quadratics that we're not going to have time for during this unit, unfortunately. But I still want to show it to you because it's actually where the quadratic formula comes from. So we are going to be using the quadratic formula to solve quadratics, but the quadratic formula is not something that just falls out of the sky. There's actually a very logical process to derive it. So I at least want to show you that. You'll not be expected to kind of repeat any of this. This is purely enrichment, but I do think that it is worthwhile. And this completing the square process kind of hinges on something that we saw before. So there's two quadratics here and here. And you know how to solve both of these. You'll do it in different ways. And so if you factor the top one, you can go x plus 3 times x plus 7 equals 0. And you can say x is equal to negative 3 or x is equal to negative 7. If you do it this way, you can say x plus 5 is equal to plus or minus the square root of 4. It means x plus 5 is equal to plus or minus 2. Subtract 5 from both sides, and you get x is equal to negative 5 plus or minus 2. And if you do that out, negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. And you see, that actually gets to the same answer. And that's because these two equations are the same equation, just written in different forms. And so what the quadratic formula does is it's the way of taking anything in this form, right, with a b term where we can't solve it with inverse operations, and transforming it into something that looks like this, where you can. And so I'll show you how to do that down here. So the first thing I'm going to do, and of course there's a missing x there, is subtract 21 from both sides. You get x squared plus 10x is equal to negative 21. And now this is kind of where the magic happens. What I'm going to do next is I'm going to add 25 to both sides. Add 25 there, add 25 there. We get x squared plus 10x plus 25 is equal to 4. And well, you might be asking, where did this 25 come from, right? Why did I just pick this random number and add it to both sides? Well, the reason why is because if you notice here, we have x squared plus 10x plus 25. Well, that's a perfect square trinomial, right? We can factor that to be x plus 5 squared is equal to 4. And so now we're back to, right, we've effectively taken x squared plus 10x plus 21, and we've transformed it to be x plus 5 squared equals 4, something that we can solve using inverse operations. And so the quadratic formula is derived by doing exactly that, by kind of taking something like this, moving the constant over there, adding something to make it into a perfect square trinomial like we did down here, and then factoring that square and then solving using inverse operations. So I'll do that derivation here. Like I said, this is purely enrichment, but I think it's interesting, so I recommend, if you have the time for it, that you follow along. I'm going to start by actually dividing everything by a here, just because that a in front of the x squared is a little pesky. So I'll go divide everything by a, and that turns it into x squared plus b divided by ax plus c divided by a is equal to 0. And now I'll subtract c over a from both sides, kind of mirroring what I just did a second ago. That's a squared plus b over ax is equal to negative c over a. And at this point, I'm going to add something to both sides. I'm going to add b squared over 4a squared. b squared over 4a squared. And you very well might be asking, where is that coming from? And you'll see in a minute that if I go 4 x squared plus b over ax plus b squared over 4a squared is equal to negative c over a plus b squared over 4a squared. Now what I have over here, this is actually a perfect square trinomial, right? This is x plus b over 2a squared. Because you'll get x squared, and then you'll get b over a, which is essentially 1/2 b over a times x, but you'll have two of them, so it'll add to a whole b over a. And then b over 2a squared is b squared over 4a squared. So I add this term to make it into a perfect square. And then what I'm going to do over here, just to clean it up a little bit, is I'm actually going to multiply. So I'm going to take this negative c over a, and I'm going to multiply it by 4a over 4a. Right, 4a over 4a, that's equal to 1, so I'm not changing the value of it, plus b squared over 4a squared. And the reason for doing that is I want a common denominator. So when you multiply these first two numbers there, I'm going to get negative 4ac over a times 4 times a. That is 4a squared. And that's plus b squared over 4a squared. So now that we have a common denominator, we can rewrite this whole thing as x plus b over 2a squared equal to, I'm going to write this b squared minus 4ac all over 4a squared. So you'll notice that I'm just taking that b squared, subtracting that. So I have a common denominator there, so I can put it all as one fraction, and I'm just switching the order of those two. B squared minus 4ac. And now what I'm going to do, I'm going to take the square root of both sides. So that means x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. And here I'm going to use our radical property, right? Remember the square root of a over b. We can do the square root of a over the square root of b. So I'm going to do that here. I'm going to call this the square root b squared minus 4ac all over the square root of 4a squared. That's going to be the square root b squared minus 4ac all over, and now we have the square root of 4a squared. Well, that's 2a. So now I've transformed this equation to be, right, we still have this as our left side. X plus b over 2a is equal to plus or minus, which I lost my plus or minus along the way here, so let me add that. Plus or minus the square root of b squared minus 4ac all over 2a. I'm going to subtract b over 2a from both sides, minus b over 2a. I'm going to get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then I can combine, because I have a common denominator there, I can combine those all into one expression. We'll call that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So all of that is just to say that the quadratic formula, it doesn't just appear, right? It doesn't fall out of the sky. There is a very logical way to find it. What you're doing is you're taking some trinomial. That's not what I meant to do. Let's go back there. You're taking some trinomial that has a b term, so you can't solve it using inverse operations, and you're making it into a perfect square. You are completing the square, and then you're solving with inverse operations. And so once we have this formula, we don't need to concern ourselves with that. We just plug in and solve. And that's what I'm going to be doing. That's what we're going to be doing in class, and that's what I'll be doing in a different video.